We've talked about making conjectures. So we're in section 2.6, our last section in chapter 2. We're going to talk about proving angles congruent. So we've talked about making conjectures, and we know that our conjectures, things that we think are true, are not necessarily true. Well, today we're going to show what we do to prove a conjecture. We talked about that a little bit yesterday, to prove a conjecture. Well, once we prove a conjecture, then we call it a theorem. So a theorem is a conjecture that we've proven true. And then once we prove a theorem, once we know it's true, then we can use that theorem to prove other theorems. So yesterday we said we start with postulates, things that we assume are true, definitions or properties, and then we prove things using those. Once we prove them, then we can call them a theorem. And then when we know that's true, we can use the theorem to prove other things are true. So we have enough information now to prove some of the theorems that we've talked about in chapter 1. So we talked about, in chapter 1, one of the things we talked about was vertical angles. So let's draw a picture here and draw a set of vertical angles. So we get vertical angles here when two lines cross, and I'm going to number these 1, 2, 3, and 4. And in chapter 1, who remembers, what did we say about angles 2 and 4? How do their measures compare? They're equal, they're the same, right? And angle 1 and 3? We said the measures of those angles were the same. So we said vertical angles were congruent. So we said that was our theorem. That our vertical angles are congruent. Well, today we're going to prove that. So we're going to say, we're going to prove, we're given that angle 1 and angle 3 are vertical angles. So we'll just use those two. I could do the same proof for angle 2 and angle 4. It's really the same thing. It just depends on which one we pick. So we're going to prove that angle 1 is congruent to angle 3. So we'll do a 2-column proof here. And we'll use our properties for our reasons. So here are our statements and our reasons over here. So let's sketch out, looking at this picture, let's sketch out how we're going to prove this. What do we know about angles, angle 1 and 2? What kind of angles are those? We talked about these yesterday. They're supplementary. When we call them, what special name did we give those to? What is it? Linear. It's a linear pair. So these two are supplementary, they're a linear pair. So that means their measures add up to 180. Well, how about angles 2 and 3? Same thing for those two. So we're going to add these two angles up to equal 180. We're going to add these two angles up to equal 180. Well, they have angle 2 in common, so we're going to subtract that, just like we did with the segments yesterday. So we're going to get they'll have something in common, and then we're going to subtract that common part away. So that's kind of our plan. So let's start out. We'll write out, usually we start out our proofs with what we are given, not necessarily, but usually. So I'm going to say angle 1 and angle 3 are vertical angles. And I'm going to use some abbreviations here so we don't have to write quite so much. And that's a given. We're given that that's true. And we know that we just said that measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 2 plus the measure of angle 3 equals 180. And for that we can say they're linear pair or supplementary. All right, so almost like we did yesterday, these two things are each equal to 180. So what can we say about this plus this and this plus, what can we do with those two? If this equals 180 and this equals 180, what does that tell us about these two things? They're symmetrical. They equal each other. If this equals 180 and this equals 180, they have to equal each other. So we're going to say measure of angle 1 plus a measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And the idea here, I'm going to use a highlighter, is what I've done is I am taking, let me do it the other way, let me undo that. I'm taking this, which we know equals 180, and I'm substituting it, I'm putting it in this equation right here. So we're going to call that substitution. Took this and put it in here for the thing that it was equal to. All right, now we're almost done. What can we do with the measure of angle 2 on both sides of this equation? We can just subtract, right? This is just a number. So I'm going to say that then the measure of angle 1 equals the measure of angle 3. So we subtract it. And then we know their measures are equal. We were supposed to prove that they were congruent, so I can say angle 1 is congruent to angle 3. And I could say for that the definition of congruent. If their measures are equal, then they're congruent. That's how we define congruent angles. They have the same measure. So now we've proved that vertical angles are congruent, just with a few steps. So not a complicated proof. So now we can say that we've proved our theorem. And our reasons were some properties. So now we have this nice theorem that we're going to use a lot in this class. So questions on what we did to do that proof? And again, most of the time when you guys are working on proofs, you won't have to start and come up with everything from scratch. You'll be filling in reasons, you'll be filling in some statements, kind of filling in the blanks with some guidelines already. All right, so let's look at how we're going to use this theorem. We've done this a little bit already, so let's look at an example of how we're going to use this. So let's say we have my problem is set up like this. And we know that this is 2x plus 42 degrees, and this angle is 3x minus 10 degrees. And we want to find x. So what do we know about these two angles now? Or what did we just prove about these two angles? We proved they're congruent. So how can I set up my problem? 2x plus 42 equals 3x minus 10. They're congruent. They have to equal each other. And now this is easy, right? We know how to do this. So what do we want to do next? What do you think we should do here, Hunter? So we're trying to find x. So when we have something set up like this, what is our goal? We want to get x by itself, right? So how combine like terms, okay? So I have a 2x on this side and a 3x on that side. So how can I combine those two? Do we want to add? This is positive, so we need to subtract. There we go. I have 42 equals 3x minus 2x is just x minus 10. And now I'm home free. Add 10 to both sides. And I get x equals 52. And I just used a property there, didn't I? Here I would have written 52 equals x, and I turn around and said x equals 52. What's a property that says I can turn it around the other way? Someone said it. Symmetric. I can take it and write it either way. So it's like a mirror. I can turn around. So that's I use a symmetric property without even saying it. Yes.
Does it matter if it is x
No.
in front of it?
No, it doesn't. Usually, this is just usually how we write it. Just x equals 52. But it's not wrong to write it the other way. All right. And so we found x. How can we check if we got the right answer? Plug it into each of these, and when I plugged it into each of those, what should I get? If I plug it in here and I plug it in here, how should those two compare? They should be the same. So I could check my work if I wanted to. I could say 2 times 52 plus 42. That gives me 104 plus 42 is 146. And if I plug it into the other ones, 3 times 52 minus 10 equals 156 minus 10, or 146. So I get 146 either way. So that's a way I could check my work, make sure I did it correctly. And that says this angle is 146 degrees and that angle is 146 degrees. So we checked our work. So what I want to do next is do one more proof that has to do with angles, and then we will talk about a couple of things that come out of this proof, a couple of similar ideas, and that's really all we're going to do today is do these couple of proofs. Remember about vertical angles, and then we're going to do some practice with our properties and with vertical angles. All right, so let's look at another proof. The congruent complements theorem. And I'm not going to ask you guys to remember these names. They give them names, they number them in the book. But we should remember what this is telling us. So our congruent complements theorem. The congruent complements theorem says that angles complementary to the same angle are congruent. So let's draw a picture here of what this is telling us. So there are some angles. Make the vertex here a little bigger. There we go. This is angle 1, this is angle 2, and this is angle 3. So this says angle 1 plus angle 2. I guess we need a measure. Measure of angle 1 plus the measure of angle 2 equals 90 degrees. And the measure of angle 2 plus the measure of angle 3 equals 90 degrees. Complement means they add to 90 degrees. If this is true, that means that angle 1 is congruent to angle 3. That's what the congruent complements theorem tells us. These two add to 90 degrees, and these two add to 90 degrees. So angle 1 and angle 3 must be the same, have the same measure. They must be congruent. So we're going to prove this. So I'll put my statements here and our reason over here. So, does anybody see how we might proceed with this? It's almost, the way I wrote the theorem almost tells us how we're going to do this. If we know that these two add to 90 and these two add to 90, what can I do with those two things? If this equals 90 and that equals 90, how do these two compare? They're the same thing, right? If this is 90 and that's 90, each of these is 90, so they have to be equal. Well, they have this measure of angle 2 in common here in the middle, but then I subtract that out. So it's almost the exact same proof that we just did. So we can use the same idea to do this, and we did the same thing yesterday as well. So we're going to say that measure of angle 1 plus a measure of angle 2 equals 90 degrees, and measure of angle 2 plus a measure of angle 3 equals 90 degrees. We'll say that's given. Yes?
Do you have to have little m before it?
Yes. M means the degree. That's the measure. If you just write the angle, then you're saying the angle is equal. So we wouldn't write that, we would say congruent if we were saying they were equal. So yeah, M tells us we're measuring. So this is given. We could put one step in here before and say that angle 1 and angle 2 are complements, and angle 2 and angle 3 are complements. That's what we start with. And then say we know this because that's the definition of complementary. But we could add a step here if we wanted to. So now from what we just said, just like we did before, I'm going to take this. This equals 90 degrees, and I'm going to substitute it right here for that 90 degrees. So I'm going to say measure of angle 1 plus a measure of angle 2 equals measure of angle 2 plus the measure of angle 3, and I'm substituting this in here for 90 degrees. And now what can I do with that measure of angle 2 that's on both sides of the equation? This is adding on both sides of the equation, so I can subtract it. And that's going to be subtraction. And then I can say angle 1 is congruent to angle 3. So the measures are the same. That means they're congruent, and that's the definition of congruent. So now we proved another theorem. If we know that two angles are complementary to the same angle, then they both have to be equal to each other. The measures have to be equal to each other. And we use the same process that we've done in the last couple of proofs. All right, questions on that one? So a lot of times students, at the beginning when we first start doing proofs, it's a little confusing. As we do more, as you see more of them, as you see more examples, as you practice with it a little more, it gets a little better and better, little by little. All right, so let's talk about a couple of similar theorems that we can prove in the same way. We're not going to go through the proofs. They're very similar to what we just said. The first one is congruent supplements. So we're going to say the same thing that we said about complements, but this time we're talking about supplements. So we're going to say two angles supplementary to the same angle are congruent. And we'll draw a little picture here. So there are my three angles. And that's 1, 2, and 3. We're saying angle 1 and angle 2 are supplements. And angle 2 and angle 3 are supplements also. So angle 1 is congruent to angle 3. The exact same idea. These two add to 180 degrees. The measures of these two. The measures of these two add to 180 degrees. So this one and this one have to be the same measure. And we would prove it exactly the same way. We would set it up exactly the same way, but instead of adding them up to 90 degrees, we'd add them up to 180 degrees. Be the same thing. Another similar theorem is that all right angles are congruent. So if we know that an angle is a right angle, it's congruent to any other right angle. So angle 1 and angle 2 are right angles. So angle 1 is congruent to angle 2. And that one's really easy to prove. What is a right angle? What's the measure of a right angle? 90 degrees. Did I say angle 1 and angle 1? Angle 1 and angle 2. So measure of angle 1 and measure of angle 2 are 90 degrees. So their measures are equal. That means they're congruent. So that's our second theorem that's similar to what we just talked about. And then the next one is that angles that are congruent and supplementary are, and let's see if we can figure this one out. We have congruent angles that are supplementary. Supplementary means they add up to what? 180. They're congruent, so each of them has to be what? What kind of angle? Right, and they have to be 90 degrees. If they're equal and they add up to 180, each one has to be 90. So we're going to say that angles that are congruent and supplementary are right angles. And in symbols, we'd say angle 1 congruent to angle 2, and the measure of angle 1 plus the measure of angle 2 equals 180. So measure of angle 1 equals the measure of angle 2 equals 90 degrees. And we can use that kind of idea with lots of different angles. So if we had two congruent angles that added up to 100 degrees, what would each one have to be? 50. If we had two congruent angles that added up to 90 degrees, what would each one have to be? 45. So we can use that idea for lots of different kinds of angles. So now we know several different things about angles, and we can use these to solve problems. We can use these to do other proofs. All right angles are congruent and supplementary, and they're right angles. Two angles that are supplementary to the same angle are congruent, and the other proof we did, angles that are complementary to the same angle are congruent. And we also have our vertical angles that we knew about before, but we just proved today. So the homework for today has to do with vertical angles, and will also have to do with some proofs that have to do with showing that angles are congruent. And then we'll do some more practice also with our properties from yesterday. The addition property, division property, all those different properties. So this is the end of chapter 2. Do a little more practice on Friday, review on Monday, and then we'll have our test. So questions on what we learned about angles today? Okay. Just adding a little bit to what we talked about before. So I'm going to stop this. We'll go over